Today we are going to work on the lead code problem subsets. So this problem has been categorized as a common Amazon coding interview question, and so given an array of unique numbers, we need to generate all possible subsets from it. So here's an example where they're given this integer array 1, 2, 3. So these are different combinations that can be generated. They also have like a empty list, a list with one element, a list with two elements, and finally the entire list. So yeah, for problems like this, the easy way to solve is using recursion. So when we are using recursion, what we could do is we can traverse down the integer array, and at each index we can either decide to add or not add the current element, and we keep doing it and saving the combination that is generated. So yeah, let's get started. The first thing we're going to do is create a result list which we're going to use to store the different combinations, and I'm going to store it outside. So let's see. I think you need to say that private, but yeah. And the first thing I'm going to do is add an empty list, because that's one of the combinations that can be generated. So now we're going to call a recursive function which will generate the different combinations. So we're going to pass the integer array itself, so nums. We're going to pass an index to it, and then we are going to pass a array list. So this is the one which is used to store the current combination. So and finally we're going to return the result. So now let me just code the current recursive function. So private void. So the first thing we're going to pass is the integer array itself. So int, and then an index, and then finally a list. So generally when we have a recursive function, we have a base case and a recursive case. Here the base case would be if the index has reached the end of the integer array. So if greater than equal to nums dot length, return, else. So like we said, the way we are going to solve it is every time we are going to decide whether or not to include the current number at the index. So first let's create a different list, and this is the one which is used to add the current element. So list, and we are just going to clone the values inside of the current list. So I just noticed the name is list here too, so I'll just change it to list 1. So this is going to actually create a new list and add all the values from the previous combination. So and list 1 dot and here we're going to add the result. So after we do that, let's now call the two methods recursively. So in first case we're going to call it using the original list which was passed to us. So here we haven't added the current number at the index, and we're just allowing it to call it recursively to see other combinations that can be generated. And here we'll add the element, so subset num. So yeah, now let's try running the solution. So yeah, all the three use cases have passed. Submit. So yeah, so the runtime complexity will be exponential. So it'll be 2 to the power of n, where n is the number of elements in the integer array. This is expected because pretty much every time we'll have to check what are the different combinations that can be generated. So we are checking at each index. Okay, for this index, we are going to add the value to the list, and this one we're not going to add it to the list, and then we keep calling it recursively. So exponentially, I think there'll be runtime complexity will increase. For memory, we are creating an array list, but we need to create one for every combination. So that too will be exponential.